Hello guys, I am Fahad Iqbal. Welcome to my channel Comparative Physics. In the previous lecture, I have discussed Coulomb's law. Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So if Q1 and Q2 are two charges separated by a distance r, then in air or vacuum the force equation is given by 1 upon 4 pi epsilon naught Q1 into Q2 by r square. And in another medium the force equation will be given by F equals to 1 upon 4 pi epsilon naught epsilon r Q1 into Q2 by r square, where you know that epsilon naught is permittivity of free space and epsilon r is the relative permittivity. Since force is a vector quantity, it is better to write force in vector form. So here in this lecture we will learn how to write Coulomb's law in vector form. Consider two like charges Q1 and Q2 separated by distance r in vacuum, as I can draw here. So here Q1 and Q2, this is Q1, this is Q2. These two are separated by distance, suppose this is r. Okay, so let F21 is the force on Q2 due to Q1, and F12 is the force on Q1 due to Q2. That is, if Q1 is exerting a force on Q2, you know that the direction of force will be here, F21. And as I said, these two are like charges, so of course they will repel. Okay, and if Q2 is exerting a force on Q1, then the direction will be here, and the force that you can write F12, that is force on 1 due to second charge. Okay, so and also you need to write the unit vector, that is r12 cap, which is unit vector pointing from Q1 to Q2, unit vector pointing from Q1 to Q2, and R21 cap, which is equal to unit vector pointing from Q2 to Q1. So what does Coulomb's law states? So according to Coulomb's law, you can write, according to Coulomb's law, what can you write? Force on second charge due to first charge can be written as 1 upon 4 pi epsilon naught Q1 into Q2 by r square and R12 cap. So remember here, F21 is force on second charge due to first charge. Okay, And here the position unit vector we are writing r12 cap. It means the direction of force is from first charge to second charge, that is from q1 to q2, and so you can see the direction will be here, f21. Is it clear? Similarly, you can write force on first charge due to second charge, f12. That will be written as 1 upon 4 pi epsilon naught q1 into q2 upon r square, and for unit vector you have to write here r21 cap, that is the direction of the force is from second charge to first charge. Okay, well, so these equation, suppose this I am writing, if this is equation 1 and this is equation 2, so you can say equation 1 and 2 express Coulomb's law in vector form. Let me write equation 1 and 2 express Coulomb's law in vector form. Okay, well, let us now discuss the importance of vector form. Okay, importance of vector form. First point I can write here, the vector form shows that forces F21 and F12 are equal and opposite. That is, the vector form shows that forces F21 and F12 are equal and opposite. Okay, since from the previous equation you have F12 equals to 1 upon 4 pi epsilon naught q1 q2 upon r square r21 cap, and F21 equals to 1 upon 4 pi epsilon naught q1 into q2 upon r square r12 cap. So you know that this r21 cap and r12 cap, these two are unit vectors. These are equal in magnitude but opposite in direction. That is, you can write r21 cap equals to minus of r12 cap. So using this equation, in this you can write, this equation can be written as 1 upon 4 pi epsilon naught q1 into q2 upon r square into minus of r21 cap. So you can write minus, just take this sign here, 1 upon 4 pi epsilon naught q1 into q2 upon r square r21 cap. And you know that this is nothing but, this equation is equals to F12 with minus sign. So you can see from here F21 equals to minus of F12. So you can see from here the two forces are equal and opposite. What do you see from this equation? You can see that this equation follows the Newton's third law. Every action has equal and opposite reaction. It means the two forces are equal in magnitude but opposite in direction. Okay. The next point I want to write here is electrostatic force is conservative. Electrostatic force is a conservative force. What is the meaning of conservative force? That is work done by the electrostatic force over a closed path is 0. Let us now write force between two charges in terms of position vectors. So consider two like charges Q1 and Q2 located in vacuum at positions A and B respectively. Okay, let us draw the figure. So suppose this is x-axis, this is y-axis, and this is z-axis. Here is the origin. So here is the charge Q1 at point A, and here is the charge Q2 at point B. So let the position of A and B with reference to the origin O of the coordinate frame be given by, this is given by R1 and this is given by R2. Okay, so here you have the force F21, that is force on second charge due to first charge, and here is the force on first charge due to second charge F12. Okay, so we'll let that the position of A and B with reference to the origin O of the coordinate frame be given by position vectors r1 and r2 respectively. Okay, we have shown it in figure. So again, you see that here a charge q1 which is at point A and another charge q2 which is at point B. And suppose that the position of q1 with respect to origin is r1 and the position of q2 with respect to origin is r2. Okay, so that is, I can write OA equals to r1 and OB equals to r2. So using triangle of vectors, using triangle law of vectors, we have what? OA plus AB equals to OB. Okay, so I want to draw it here. Suppose this is OA and this is OB, and so you can write here this is as AB. So this is R1 and this is R2. So you have AB equals to OB minus OA. That is, OB is R2 and OA is R1. So I can write R12 equals to R2 minus R1. So here you can represent this as R12. Okay. So now, according to Coulomb's law, force on Q2 due to Q1 is F21 equals to 1 upon 4 pi epsilon naught Q1 into Q2 upon R12 square and R12 cap. Well, so, and you know that R12 can be written as R12 upon its mod R12. Okay, so this equation now it becomes 1 upon 4 pi epsilon naught Q1 into Q2 upon, so here, okay, if you substitute this equation here, it will become R12, and in denominator you have the mod, so this mod and this R12 square, this will become R12 cube. Okay, so finally you can write F21 equals to 1 upon 4 pi epsilon naught Q1 into Q2 upon, so what is R12? R12 is R2 minus R1. Okay, so R2 minus R1 mod cube. Okay, and for R12 you can write here R2 minus R1. Okay, so this is, we have written the force on charge q2 due to q1 in terms of its position vector. Similarly, you can write force on charge q1 due to q2 as 1 upon 4 pi epsilon naught q1 into q2 upon r1 minus r2 mod cube and r1 minus r2. So thus we have just expressed the forces in terms of its position vectors. Let us now discuss the superposition principle. The superposition principle. So we know that if we were given two charges, the electrostatic force between them can be found by using Coulomb's law. However, if a number of charges are present, then force on any charge due to the other charge can be found by superposition principle. So what is superposition principle? It states that when a number of charges are present on a when a number of charges are present, the total force on a given charge is equal to the vector sum of the forces due to the remaining charges on the given charge. Suppose here is the charge q1, here is the charge q2, and here is the charge q3, and so suppose there are n number of charges, and here if I say here is the charge qn, I suppose. Okay, then the force on charge q1 due to q2 will be in this direction. Okay, F12, and if the charge the force due to charge q3 on q1 will be in this direction. Similarly, the force on q1 due to charge qn will be here, F1n. So therefore, if you wish to find the net force on q1 due to all other forces, then what you have to do? You have to find the forces between each charges, okay, and then sum up. So force on first charge, force on first charge due to second charge will be given by 1 upon 4 pi epsilon naught q1 into q2 upon, and suppose this distance is r21. Okay, this distance is r31. Similarly, this distance will be rn1. Okay, well, so 2 1, here is the 3 1 and n1. So this will be r21 square r21 cap. Similarly, on force on first charge due to third charge will be 1 upon 4 pi epsilon naught q1 into q3 upon r31 square r31 cap, and so on. The force on first charge due to nth charge will be 1 upon 4 pi epsilon naught q1 into qn upon r n1 square r n1 cap. So the net force on charge 1 will be force due to second charge on first plus force due to third charge on first, and so on up to force due to nth charge on first charge. Okay, so if you substitute all those equations here, I have 1 upon 4 pi epsilon naught q1 q2 upon r21 square r cap 21 plus 1 upon 4 pi epsilon naught q1 into q3 upon r31 square r31 cap plus and so on 1 upon 4 pi epsilon naught q1 into qn upon r n1 square r n1 cap. So you see that something is common. So what is common? q1 upon 4 pi epsilon naught is common in each term. Okay, let us take it out. q1 upon 4 pi epsilon naught. So what you are left with? q2 upon r21 square r cap 21 plus q3 upon r31 square r cap 31 plus and so on qn upon rn1 square rn1 cap. So now we can write this in terms of summation as net force on first charge equals to q1 upon 4 pi epsilon naught. You can see this is q2, q3 and so on qn, and similarly 2 1 3 1 and so it is going to n1, and for unit vector are going 2 1 r cap 2 1 r cap 3 1 and so on r cap n1. So this term I can write sum over I equals to 2 to n qi upon r i1 square r i1 cap. So this is the shorthand notation in terms of summation. So this is what is known as the superposition principle. So basically superposition principle is nothing but you have to just find the sum of the sum of the forces due to all other charges on the charge or at which you want to find the net force. Okay, so I hope you are learning through my videos. So please like and share my videos and subscribe my channel to learn more. Thank you for watching.